And let's look at our second example in the notes. Okay, we're still in the non-constant growth model setting. So we have two stages. In the first stage, our growth rate is 0% for 3 years. In the second stage, we have 6% as our constant growth rate, G2. Okay, so step 1, we need to calculate dividends from year 1 to year n plus 1. So in this case, we need to calculate from D1 to D4. Okay, n is 3, so we calculate D1 to D4. For calculating D1, it is D0, $2, multiplied by G1, 10%. So we have $2, okay, 0% growth rate in the first stage, so the dividend does not change. Same apply to D2 and D3, okay. D1, D2, D3 are all $2 because our growth rate in the first 3 years are 0%. For D4, it is D3 multiplied by 1 plus G2, so $2 multiplied by 1 plus 6%, we have 2.12 as D4. And for step 2, we calculate P3. It should be D4 over RS minus G2. So we use 2.12 divided by 13% minus 6%. We have 30.29. Step 3, we want to calculate P0. So we discount from D1 to D3 and also P3. So we input cash flow 1 as 2, cash flow 2 as 2, plus, I think, okay, so there are two ways. You could either input cash flow 1 as D1, cash flow 2 as D2, cash flow 3 as D3 plus P3, or you could input cash flow as $2, and because D1 equals D2 equals 2, we can input frequency 1 as 2. So both D1 and D2 are already inputs. So for cash flow 2, you can input D3 plus P3. Okay, so it's 32.29 altogether. And frequency 2 is 1. Okay, in the first method, we can input D1, D2 separately, but frequency for each input should be 1. Here, we can input them together, make frequency 1 as 2. Okay, and we go to MPV, I is 13, compute for MPV, we have 25.72. Okay, so if I show you on the calculator, I could have cash flow function, cash flow 0 as 0. Again, we do not input D0. Cash flow 1 is $2 here. Enter. Down button. Frequency 1, 2. Enter because we have two $2. Down button. Cash flow 2, 2 D3 plus P3. 30.29 equals 32.29. Okay, enter. Down button. Frequency 2, 1. Make sure we have 0 as cash flow 3, 0. Okay. Excuse me. Okay, 0 as cash flow 4. Okay, and we go to MPV. I should be 13 still. 13. Enter. Down button. Compute for MPV. 25.7128 as P0. Okay. For dividend yield and capital gains yield for the first year, by definition, dy is d1 over p0. So we can calculate that. The dy equals 7.78%. Capital gains yield becomes R minus dy, so it's 13% minus 7.78%, which is 5.22%. After 3 years, it's in the constant growth model setting, so dividend yield becomes R minus G, capital gains yield equals G. Okay, so in the fourth year or in any year after the third year, dividend yield becomes 7%, capital gains yield becomes 6%. Okay, so here are two examples of how we address questions with two-stage constant growth rate, or we could also call it non-constant growth model. Okay, here in the second part of the notes, we have 3 practice problems, and they're all two-stage model. Okay. You can try to work on these questions by yourself without looking at the solutions first. Okay, and then once you practice all these 3 questions, you should be more familiar with the 3 steps of the two-stage model. Okay, you can pause the video now to work on all these 3 questions. And you can resume the video if you finish working on them. And you could listen to my discussion of the solutions for these 3 problems once you finish them. Okay, so if you are ready, if you have worked on these 3 questions on your own, let's look at the solutions now. Practice 1, we have this firm that has a last dividend of 1.75. Okay, last dividend, again, it should be D0. Its dividend growth rate is expected to be 25% for 2 years, after which dividends are expected to grow at a constant rate of 6% forever. So G1 equals to 25%, G2 equals to 6%, N equals to 2. Required return RS is 12%. What is the best estimate of current stock price? Okay, we know all these conditions. Our step 1 is to calculate dividend. Calculate D1, D2, and D3 because our N is 2. So we calculate from D1 to Dn plus 1. D1 equals D0 multiplied by 1 plus G1. D2 equals D0 multiplied by 1 plus G1. D2 is also D1 multiplied by 1 plus G1. D3, however, is D2 multiplied by 1 plus G2, or it is D0 multiplied by 1 plus G1 squared multiplied by 1 plus G2. Step 2, calculate horizon value, P2. Okay, because our N is 2, so we calculate P2, that is D3 over RS minus G2, because when we calculate horizon value, we're discounting all the dividends in the second stage. We use constant growth model in the second stage, so we use the growth rate in the second stage, G2. Step 3, we input cash flow 1 as D1, cash flow 2 as D2 plus P2. Okay, we input until Dn plus Pn. Okay, you can input these 2 numbers, enter I as 12, the stock return, RS. Okay, it is given as 12. Okay, given as 12. So we have, and then compute for NPV, we have 42.64 as our stock price. Okay, this is how you work on it using our 3-step method. You can also, this graph here shows how you can do it manually. Again, we have last dividend D0 as 0.75, short run growth rate 25%, G1, long run growth rate 6%, G2, required return R 12%, and we have year 0, 1, 2, 3. Okay, so for year 1, 2, we have G as 25%. For year 3, we have 6% as our G2. The dividend at time 0, D0 is 1.75. D1, D2, D3 can be calculated using our formula shown below. P2 is D3 over RS minus G3, or G2 here. So G3 here means the growth rate in the third year, which is the same as our G2, the growth rate in the second stage. It's 48.373. And then if we want to discount them manually, okay, for time 1, the total cash flow is D1, 2.1875. For time 2, the total cash flow is 2.7344 plus 48.373, so it's 51.0417. It's D2 plus P2. Okay, and then in order to get present value of these two cash flows, we can use this 2.1875 divided by 1 plus 12%, so we have 1.9531. Okay, we can discount them manually if we do not use the cash flow function. For D2 plus P2, you can discount by dividing by 1 plus 12% square, so you have 40.6901. Okay, and then you add these two numbers up, you would have the sum of the present values, which is 42.64 as our stock price. Okay, this is showing you how we can discount D1 and D2 plus P2 to have two present values and add them up for having the stock price. Okay, this is an alternative method as opposed to our cash flow, using cash flow function to discount the two cash flows. Practice 2, we have another firm, and we know dividends are growing at a rate of 18% for the next 3 years. And then after that, it's going to be 6% growth rate. So we have G1 equals to 18%, G2 as 6%, and as 3. The annual dividend per share is estimated to be $4 in the next year. So D1, because it's next year, so D1 equals to 4. Required rate of return 15%, RS 15%. What is the highest price you are willing to pay for a share of the firm's common stock? Okay, so again, we use 3 steps. Step 1, because n is 3, so we calculate from D1 to D4. Dn plus 1. D1 is given $4. D2 is D1 multiplied by 1 plus G1. D3 is D2 multiplied by 1 plus G1. D4 is different because it's in the second stage, so we use D3 multiplied by 1 plus G2. Okay, D1 to D3, we use G1. D4 in the second stage uses G2. Horizon value P3 equals D4 over RS minus G2. Again, it's in the second stage, we use G2. P0 inputs cash flow 1. Okay, so here it should be C1. Cash flow 1 should be D1. Cash flow 2, D2. Cash flow 3, D3 plus P3. I, stock return 15. Compute NPV. We have 53.84 as stock price. Practice 3. This firm already paid 6 dividend per share this year. So is it D0 or D1? Already paid. Yes, it should be D0. Okay, D0. Already paid, just paid, meaning D0. We expect dividends to grow 10% annually for the next 4 years. Okay, so G1 equals to 10% for 4 years. And after that, we have 7% growth as G2. Okay, and our N equals to 4 here. If the company decides to invest in a new technology, it estimates that the dividends will not increase for the next 5 years, but the growth rate of the dividends will be 11% thereafter. Okay, so if we do not invest in the technology, G1 is 10%, G2 is 7%, and N is 4. If we invest in the new technology, G1 is going to be 0 for 5 years, and G2 is going to be 11%. Okay, in the second case, we would have G1 equals to 0, G2 equals 11%, N equals to 5 if investing in the new technology. There are 2 cases here. Required rate of return, RS, is 17% for both cases. In order to maximize the shareholder value, should the company invest in the new technology or not? Okay, we want to maximize the shareholder value, meaning we want a higher stock price. We need to calculate stock price for both cases and see which one is higher. So we would decide whether to invest in the technology or not. Okay, conditions for both. D0 again is $6, R is 17%. In the first case, not investing, we have G1, G2, and N here, 10, 7, 4. Step 1, we calculate from D1 to D5 because our N is 4. D1 is D0 multiplied by 1 plus G1. So it's 6 multiplied by 1 plus 10%. We have 6.6. D2 is D1 multiplied by 1 plus G1. D3 is D2 multiplied by 1 plus G1. D4 is D3 multiplied by 1 plus G1. D5 is special because it's in the second stage, and it's D4 multiplied by 1 plus G2, 1 plus 7%. Okay. Step 2, P4, horizon value equals D5 divided by RS minus G2. Step 3, we input cash flow 1 as D1, cash flow 2 as D2, cash flow 3 as D3, cash flow 4 as D4 plus horizon value P4. I equals 17, MPV computes 70.78 is the stock price if we do not invest in the new technology. If we invest in the new technology, our G1 would be 0, G2 is 11%, N is 5. So because G1 is 0, D0, D1, D2, D3, D4, D5, in the first 5 years, we have all the dividends equal to $6 because we don't have any growth in dividend in the first 5 years. In the 6th year, D6 equals D5 multiplied by 1 plus G2. Okay, so we use 6 multiplied by 1 plus 11%. We have 6.66 as D6. Step 2, P5 equals D6 over RS minus G2, 111. Step 3, calculating P0. Cash flow 1 to cash flow 4 is D1 to D4. Cash flow 5 is D5 plus P5, 117. I is 17. Compute for MPV, we have 69.82. So in the second stage, stock price is lower. We prefer the first stage where we do not invest in the new technology. So we say that we think do not invest is better. Okay, we want to choose the first option with higher stock